Hello, everyone, and welcome to Think Big's Jumpstart Your Big Data Project webinar. With us today is Douglas Moore, Principal Consultant and Architect at Think Big. Our goal today is to provide you with an overview of how we approach and begin our new projects and walk through a few examples with you. Note also that we do offer our own Jumpstart service. So if you have any questions about that, there's an email at the end that you can ask or that you can connect with. With that, I'll hand it over to Douglas.
Thank you, Anna, and thanks everyone for your time today. I'm excited to share how Think Big Analytics can help you take advantage of big data technologies to create value. We founded the company after working at Quantcast, one of the pioneers in leveraging Hadoop and data science technologies to build a new $100 million business in advertising. They were one of the first. And today, we're helping many more companies take advantage of the power of big data. I want to spend a minute telling you about Think Big. We provide data science and data engineering services that create value from big data. We help you imagine your possibilities for big data and identify a plan for profitable projects. We illuminate your team through training and education on the latest in big data technologies. And then finally, we help you implement your analytics plan with hands-on data scientists and engineers who rapidly build big data solutions to deliver value. So Think Big has helped companies of all sizes, from small, medium businesses to Fortune 500, all to generate value from big data. What we know for sure is this: the technology is so new that all organizations are seeking support, and as you can see here, many of them come to Think Big. So let's look at the landscape. We've seen the power of data and the innovation and competitive advantages that can be realized. It's leveraged using big data analytic techniques. Because of that, there was an explosion of products and vendors rushing to offer solutions that promise to help companies be as adept and skilled as Facebook and LinkedIn are at using data. However, the inherent problem we face is that none of these technologies are or ever will be plug and play. So how do you continue to manage innovation, identify the best use cases to start with, and develop assets to bring to business sponsors? Our view of the market is that there are 5 stages of adoption to true organizational transformation through big data. At each stage, there are and will be multiple or many big data projects, and any one of them can be quickly and efficiently jump-started with the proper planning, data sets, and pilot system. First step you want to take on is the planning side. It's important to identify use cases that have the highest priority but the lowest challenges in terms of technology or internal skills. In this graphic, we show how we did for a customer during a 5-week engagement. We lined up their projects that they had in mind. We scaled it or scored it against criteria that we mutually agreed upon, and then we identify priorities for the Jumpstart. As you can see in the rightmost column. Oops, sorry about that. So let's talk about some good use case samples for a Jumpstart. Firstly, there's the thin slice. Take high velocity data ingestion required by your device sensor network or website, and then being able to show that technology, big data technology, can be put together to ingest that data in a horizontally scalable manner and generate a key report from that data. This will prove out that big data architecture from end to end. Or perhaps your company is running into a fiscal wall. What I mean by that is facing a sharp jump in Oracle and Informatica costs associated with scaling up your ETL to the next level. We'll help you quickly demonstrate that Hadoop can prove to be a better, faster, cheaper solution to ETL. Thirdly, what if you could show the business that they can access their entire data set through the power of search? Imagine Google for your corporate data. More advanced users will use the same architecture to do detailed analysis. These days, search technology doesn't just mean finding 100,000 results out of a billion records or so, but it also means faceted searches, returning summaries in seconds, and building dashboards that are continuously updated during the ingestion of new data. Let's say that you have a fairly well-defined use case and solution in mind, but you need an expert and objective independent party to help you decide between two competing solutions. One solution, for example, could be open source technology with a support company behind it. The other solution could be a giant software company with a closed source solution and a solid standing. Jumpstart is a good way to help your team make an objective decision. Finally, many companies want to first find out, does my data have predictive value? What insights can we gain that are missing with our current BI techniques? These are all prime candidates for a jumpstart. Anna, I believe you have a poll. Hello, Anna.
Yep, no, the poll is up. And
Okay.
the question is, has your group identified use cases they'd like to explore? You guys could just take a second to answer that. Leave it up for a minute. All right, good. About 60-40, Douglas, is of folks who have identified a use case that they're interested in.
Oh, excellent. Excellent. Well, so with those use cases in mind, and after planning and prioritization, during a jump start, we quickly assess the technology and investments that need to be made to bring your big data project to life. We compare those against our reference architecture and familiar design patterns. Now, certainly you wouldn't start with a complete picture like this in a jump start, but this helps us guide our clients through the right choices and decisions in a very quick manner. So now I would like to talk about two jumpstarts examples in detail that we've worked on as a company. The first one is a ETL and big data warehouse type jumpstart where, well, I'll get into that. And then the second one is looking at the predictive powers of your data set. So in the first case, which I worked on myself, along with a team of client engineers and Think Big engineers, worked side by side. A software as a service company was enjoying steady growth and landing bigger and bigger deals. They needed to make sure their infrastructure was ready for the ongoing success. One area of concern was in transferring data from their OLTP system, their transactional system, to their OLAP, or data warehouse system. They were in danger of bursting through their SLA, and they were facing that fiscal wall I spoke of earlier, of a huge jump in Oracle and Informatica licensing costs. So a project was conceived of, planned, and executed within 5 weeks to compare the current Oracle Informatica ELT process with a process based on Hadoop. They were also interested in the big data warehouse capabilities and looking across client data sets to identify trends and insights. The result was, after examining 3 use cases, each with 2 sub-options, we were able to demonstrate that yes, Hadoop could make 80% of their load time shrink by a factor of 8. Additionally, the Hadoop software and hardware was about 10 times cheaper than the alternative. And additionally, this opened the doors to create a very valuable benchmarking set of products for their customers. So again, in the end, it saved the SLA. That was the primary need, and it went very well. So the second case study I want to talk about is an online dating site for social media users. So we kind of think of this as, big data for love, if you will. So they had 3 data science goals in mind. They wanted to refine their matching algorithm. They wanted to identify target candidates. Oops, sorry. Uh, and they want to match target candidates with other users that are likely to communicate and respond. Now, in this example, we really only have time to go into one of these in detail. So also let me add that the data scientist leading this engagement is still happily single. So in this example, the one use case we'll explore is identifying target members. The goal of identifying desirable members is informally titled hottie detection. Hottie detection is a critical path because new signups often do not re-engage the site subsequently, and it is presumed that the first email contact, should it present desirable members, can lift engagement rates. During the engagement, additional data was captured in a big data system called Splunk. So what this system did was track the activity within the site. It identified when users were presented with potential matches to favor or skip, those actions were recorded. Now, using this, we can calculate a favorite to view ratio, which describes the desirability of the user. However, these data are biased by spam and by disparities in the audience viewing users. To correct for this, we introduced a trust or pickiness factor. The final process of calculating desirability is defined as impressions, count the number of times the user was presented; favorites, count the number of times the user was favorited; the pickiness. A pickiness is scored that's based on 1 minus the ratio of the number of favorites they clicked to the number of users viewed. Trust. Define the trust of a user as their pickiness score divided by factor and adjust for the small number problem. Desirability, the result. Define the desirability user as the average of trust scores of all the users who favor them divided by the total number of impressions said user received. Again, this may be scaled to handle the small number problem. Now, this solution was executed in concert with Think Big and our client. There was 2 days of pair programming involved. The final solution was presented to the sponsoring client technical member staff. Upon finalizing code and adjusting values to produce the best results, this was then quickly pushed into production. So, Anna?
So the second poll is, which department is your business sponsor for your big data project? Interesting, Douglas. It's about 35% sales and marketing, and 35% engineering.
Excellent. Very good. Thank you. So to conclude, the Think Big Jumpstart offering is customized to get your big data project going quickly. It's appropriate for those who know what the opportunity is, having a bit of a struggle on how or where to get started, and or wanting expert guidance and knowledge transfer. You'll get definitive results and a prototype system in 3 to 8 weeks, which will deliver the assets needed to prove to your stakeholders that big data value, either better data engineering or better data science, is attainable by your company. Any questions from the audience?
Feel free to type any questions in on your panel, your GoToMeeting panel. Douglas, I have a question, or we have a question. What is the difference between the 3 to 8 week delivery time, and the um, should they expect to be able to do the same thing on their own?
Okay, good question. So well, the time frame depends a lot on how well defined the problem is, and the availability of the resources, i.e., cluster and the tech team. But it also it depends on, say, the scope of what they want to prove out as well. So those things have a big influence on the time frame. So a data science with an existing cluster and data available and experts available could be on the shorter range. Spinning up new technology with Amazon Web Services and architecture could be more on the high range. Now, the question is, could you do it on your own? Well, there are a lot of resources available now to understand big data and courses. We offer some courses. Many other companies offer courses, and there's a lot to read about. But you know, it's it's like trying to get started with when there's a whole bunch of different building blocks that need to come together, and having never done that before, or having only limited experience. And if you want to get started quickly and kind of get started down in the right direction, have a great deal of confidence that your group is headed off in a good direction the first time, then it's our advice to bring in some experts to help guide and transfer knowledge so that you can take those assets and show to your stakeholders that this is doable. And then there's also knowledge transfer during this process. So you'll be in a much better position to iterate on the results of a jumpstart, as many of our clients have done so.
We also have a question from Gerald. He's asking how big the client team is on a first engagement and what roles do they play.
Very good, Gerald. Thanks. So uh, typically there's a project director or stakeholder, with one foot in the business, one foot in the technology. There's often a systems architect that understands the current source systems. There may be a couple engineers available as well, and possibly a business subject matter expert from the client side. And so that project director is responsible for securing the resources and the time of the people involved, and of course the money and executive support as well.
All right, and we have a final question is from Fran. She is stating that they don't currently collect a lot of data. So how much data is required for a jumpstart to get off the ground and actually be able to provide some asset.
So with now not having a lot of data is somewhat relative in a way. So with a smaller data set, it depends a lot on your interests. Is your interest in data science or data engineering? This small amount of data, we can prototype, say, search. We can show how that data can be ingested and displayed and dashboard be built for business executives and decision makers, and tell a story about how and when more data is collected, that this this increased volumes of data will be handled with this scalable technology, and how the solution will work in the future. And the Jumpstart, in this case, will help tell that story. But because it's a small data set, it it will tell a portion of the story. So it'll stress more of the functionality and less of, say, the scalability. But that's perfectly fine, Jumpstart.
Okay. And one other question is coming from Chuck. He's stating that they are a large public retail company and they are interested in a big data using whether big data can help them drive foot traffic into their physical stores.
Okay, so that sounds like more along the lines of data science. That finding what factors influence foot traffic. Whether it be weather, whether it be advertising, sale, merchandise pricing, etc. And what big data can help you do is land your existing data sources into a repository, and then generate analytics of, and use data science techniques that my colleague Dan is familiar with, very expert in, to suss out what factors are most pertinent to driving that traffic. And then from that, the business can decide what actions to take. Whether it's more advertising, whether it's pricing, whether it's a combination of things on a rainy day that might affect that foot traffic. So big data can help you better understand why you're getting more foot traffic from your existing data collection, and then the effectiveness of your efforts to increase that foot traffic.
Okay,
And it can help you do this without designing a brand new data warehouse to answer those questions.
great. That's it for our questions. Thank you, everybody, for joining us. And next Thursday, we'll have a case study webinar on a company called Kantar Media, who reinvigorated in a legacy product line by using big data. Thank you very much.
Thank you, everyone.